Lesson 81, page 335, complex numbers and real numbers, products of complex conjugates, division of complex numbers. Sounds like a wonderful time. Something you just want to go to a seminar. Yeah, hear somebody talk for hours on it.
4 hours.
Okay. One thing that I want to do is take this here. And what I want you to do is, using the FOIL method, solve that one for me. Okay, what'd you get?
A squared minus b squared.
A squared
Minus b
minus b squared.
squared.
Okay. So, one of the things that you would find out if you did enough of these, for instance, if I gave you 3 plus x and 3 minus x, if you have a two-part, what would I call that? If you had a two-part number, a plus b and a minus b, and its conjugate, so a two-part number and its conjugate, two-part number and its conjugate, you know, the sign is just the opposite on the second one. One thing to remember, the first number never changes. The conjugate means the second number changes sign. Some of you made that mistake on the test where you changed the sign of everything instead of just the second one. All right, so that is a general rule that works all the time. That if you have a two-part number that you multiply by its conjugate, you will get the first term squared, always minus the second term squared. Okay? Which means your O and I in FOIL disappear. And it means you don't have to use FOIL. You just square the first term, square the second, put a minus sign in there. That's the purpose of conjugates. It makes your life a lot easier. Yeah, we have. Why, does it sound familiar or does it sound new? Okay. Yeah, we already did this. One of the things this book does is it kind of reminds you of what you've done in the past so that it can build on that and continue on. So, that brings us to 2 plus 3i over. And some of the stuff that the book goes over that appears to be showing up again is not necessarily in the book the first time. I just started talking about it too early. So you're like, oh, why have I heard that? Well, it's because I probably just made it up in a lesson before. They give you a freebie, yeah. I love these freebies. Okay, so knowing that this statement is true, and I do not want a radical sign in my denominator, we did go over this in a few previous lessons. You multiplied the top and bottom by its conjugate because you got rid of the radical sign in the denominator. Same thing that happens in complex numbers. Same thing is going to happen with our i's. If we multiply this times the conjugate, what happens is I square the first number, square the second number, and put a minus sign between them, and I've got my denominator done. So my denominator is going to be 16 minus
Actually plus 4.
4i squared,
Which makes it plus 4.
right?
Because I squared is negative.
Which brings us to the next step, which Riley has said. Because this is an I squared, and I squared equals -1, this will be a plus, and this will go away. And that's exactly what we want to happen. We want the I to go away. And once it goes away, and another thing that's important, when you multiply by its conjugate, the I will always turn into what?
What? I squared. A -1.
Exactly. It'll turn into an I squared, which is -1, so your I disappears. So actually what we're doing here is we're squaring this and changing this sign. And get rid of the I. So then this becomes a 20. 20 is a lot better than a 4 minus 2i. So we're not solving anything, we're just simplifying it. What happens to the top? Okay, we're going to FOIL it all out. So when we FOIL all of this, we end up with F gives me 8. O, I, and L. Which gives me 8 plus 16I minus
Which
6.
gives you 2 plus 16.
Which gives me 2 plus 16I. So 2 plus 16I over 20.
Would you go any farther than that?
What I would do with this here,
16 and the 20.
I would factor out a 2,
Yeah.
and then this, and get 1 plus 8I over 10. Okay, so let me give you one. I want you to try this one all by your little lonesome.
Oh my god.
I know, scary thought. Nothing scarier than being alone and seeing no hope. I wonder if that's what hell is like. Being all alone
With no hope.
in the universe with no hope.
It'll be like Barney or something.
Yeah.
You know?
There's gonna be a kid.
Okay, so anyway, simplify that for me. Okay, so when you do this, you should get the answer.
16.
Well, it's cool. Oh,
Oh, I always forget
well.
to change it.
Well then, anywhere close.
Oh, actually, where's?
So you have to write it separately.
How unfortunate.
Remember when we went over this?
Oh, yeah.
Okay? It's the same thing, because really what you would get with this is negative 16 minus 2I all over 13. That's probably what you got. Okay? In order to put it in this form, A plus BI, you have to pull the number onlys out and have your term with the imaginary or complex number as your second term.
I had it over one, and I was really confused.
You had it over 1.
I just must I left the 3 in there, so it was negative 4 plus 3. I didn't even try it.
Yes.
So
Ben.
if I got 2I plus 16 over negative 13.
2I plus 16 over negative 13.
You don't want a negative
I
in
got
the
that,
denominator.
but not
right?
negative.
That's why you change it into
I got both.
First 16 has to be first.
Okay, let's see.
A plus BI.
That is a correct answer, Ben, but it's not as simplified as it can go because of the negative sign on the bottom. So what I would do with this, if you were doing this like on a test, you would just, when this bottom is negative, you just change everything to its opposite and you're good.
You don't want a negative in the bottom.
Yeah. If you have a
Also-
negative in the bottom, change everything in the whole problem to its opposite and you're fine.
And then the top. the
And then
16.
split 'em.
Yeah, the 16 has to be first.
Yes. So, yeah. You did the hard part right. It's just doing all the other splitting up kind of junk. That, okay.
If there's only carbonated water, I would die.
So that's lesson 81. That's all there is to that.